as we progress through functions, we also need to familiarize ourselves with what is called function notation. So in this problem, this is one of the most important things that I still see students beyond Algebra 2 make the mistake of. And that is this function notation, which is actually written right here, y equals f of x. And to give you a heads up, it's pronounced f of x. And I know it's super confusing because you learned a while ago that this would kind of be written as, when you see parentheses without an operation, you think automatically to multiply. That is not the case whenever you see f of x this way, g of x this way, h of x this way, and we can actually use any letter we want. It's just f, g, and h are the most common. So let me explain what you do first, and then I'll explain what's really happening. So in this problem, you see how we're going to evaluate f of 3, and so the 3 is replacing the x in this problem, so we also need to replace the x in the rule with 3. This is called a function rule, to take your input x, multiply by 5, and subtract 2. So as you look at me evaluate this problem, just do the order of operations. You get 15 minus 2, which is 13. The reason why I like this notation so much and why it's prevalent in mathematics is because now you know, if you were to look at the graph of this, that when x is 3, y is 13. So what that means is the ordered pair is 3, 13. The y coordinate is the result of putting in whatever it is for x. And hopefully that makes sense. If not, you might need to just come to me with questions. So in the next problem, I'm following the same rule. It's not f times -2, it's f of -2, and you replace this x with -2. So again, with the order of operations, you do 5 times -2 first, and then when you subtract 2 from that, you get -12. What does that mean? That means when x was -2, we got a y coordinate of -12. And yeah, I think I've touched base on everything. So again, this is not g times 3, it is g of 3. So what that means is when you plug in 3, what are you going to get for y, the y coordinate? Well, 3 squared would give me 9, plus 4 is equal to 13. I'll actually circle the answers that we really care about, but I also want you to understand what you're finding. So g of 0 is saying when x is 0, what's the y coordinate? Well, 0 squared is still 0, 0 times 0, plus 4, you get 4. So what I really care about is the 4 as the answer, but what it means is when x is 0, y is 4. Same thing with the next one. Change colors one more time. Just a reminder that exponents are repeated multiplication, in case you forgot from Algebra 1. That 2 to the third power means 2 times 2 times 2. And when you evaluate that, you get 8. So when x is 3, the y value is 8. Same thing with the next one. You just may have forgotten that with a negative exponent, it becomes a denominator. So 1 over 2 squared gives you 1/4. So these are the values that I care about. And if you're confused by anything, we can discuss this in class. Just bring your questions to class. So another part that is, I think, very important is being able to read the mathematics. There's not a lot of math being done in exercise 2, but you need to be able to interpret what any of this means. So what we have is, this is a true statement that water boils at 212 degrees Fahrenheit. And if it's left in a room at 65 degrees and begins to cool, well, it starts at 212 and it's going to cool, but it won't cool beyond 65 degrees, the temperature of the room. So they gave you a table, but they're just asking you to evaluate t of 2. So if you read this carefully, notice it's not x and y anymore. It's h and t of h. But you can think of it the same way as x and y. So when I'm asking you to evaluate t of 2, notice in this problem it's t of h. So that's telling me that h must equal 2. So then t of 2 is the y coordinate when x, or h, is 2. So you go to find where h is 2. So after 2 hours, the boiling water is now 104 degrees. Same thing with the next one. Think of it the same way, that t of 6, so instead of t of h, it's t of 6, but that means that h must equal 6. So after 6 hours, t of 6 must equal 68 degrees. And a science teacher would tell you to put the degrees Fahrenheit there. I'm not as strict with labeling things. So why is that important? Well, if we look at the next one where they say to what value of h, so we need the value of h up here, 0 through 8, is t of h equal to 76. So now it's basically saying y equals 76. I know I put the y here. So you're going to where y equals 76. And you want to go backwards to say that happened at h equals 4 hours. And again, you don't have to put the units in there, but interpreting that answer is super important. And then the next one, hopefully this is making sense. If not, bring questions to class. But between what 2 consecutive hours will t of h equal 100? So as you're looking at t of h, it's the y coordinate. Well, it doesn't ever exactly equal 100. But what happens is to go from 104 down to 85, the only way to go from 104 down to 85 is if you cross 100 at some point. And that, time-wise, occurred between 2 and 3 hours. And for our purposes, this is a super important theme, but you will learn that important theme a little bit later in calculus. So let's just leave it at that for right now. So I'm also going to ask you to use function notation to read a graph. So as we look at this problem, we're going to ask you to evaluate based off of the f of x's graph below. Now remember, this is y equals f of x, so when I read this to you and I say f of -1, that's saying that x equals -1. So if I go on my graph, the x-axis is left and right, that right here is x equals -1. And for some of my students, what I've actually seen them do is write out the ordered pair. And remember that f of x is -1, they're asking for the y coordinate there. So f of -1 equals 0. So moving on to the next one, x equals 1. So if I ask you for f of 1, I want the y coordinate when x is 1. And for some students, I've seen them actually draw a vertical line at x equals 1. Or you could write out that ordered pair at 1, 1, 2, 3, 4. And we want the y coordinate, which would be 4 there. And try the next one on your own. You could pause the video. 1, 2, 3, 4, 5. And please don't forget, I could easily make a mistake. But I counted down 4. So remember, if you're watching the video, that you can pause it at any point. And try it on your own. So evaluate f of 0. Well, let's just do that first. And we're going to do that the same way as we did letter A. It's when x equals 0. And that hit right up here. And it's just asking you what special feature does f of 0 correspond to. If you notice that it hit on the y-axis, do you think it'll always be on the y-axis? Well, if the x value is 0, then yes, it'll always be a y-intercept. And that's the important thing that you should get out of that question. The y-intercept is always when x equals 0. Now the next one's a little bit tricky because for one, what I suggest to students to do is to not write f of x, but to rewrite y equals 0. So y equals 0 is a horizontal line. And so I encourage students to draw a horizontal line at y equals 0. And what you should notice is y equals 0 is on the x-axis, so these must be x-intercepts. Which I'm actually getting ahead of myself because I didn't answer the first question. What values of x solve the equation? Well, if x were -1, we get y equals 0. And then 1, 2, x equals 3. We get y equals 0. And then 1, 2, 3, 4, 5, 6, 7. And again, double check that I'm reading the graph correctly because I might be good at math, but I sometimes mess up counting, which is embarrassing, but we'll go ahead and do that. And then the next one's pretty similar to that. As I mentioned, sometimes I'll even ask students to draw the line y equals 3 first. So that's a horizontal line again. And now it's not asking you for the x values to solve it. It says between what two consecutive integers does the largest. So if you look at this answer, okay, that's the smallest. Largest is furthest to the right, would be over here. And that happened between 1, 2, 3, 4, 5, 6, 7, and 8. So I've even seen students draw like a highlighter in there to see that, okay, yeah, it happened between x equals 7 and x equals 8. And we've talked about integers in the previous lesson. In the next one for a function, we know that g of -2 equals 7. So which of the following points must be on the graph? Well, I hope I've explained this good enough that, remember, this is g of x is equal to y. So I think it's clear, and why I like function notation is because you can just, without drawing it over and over again, you can write out ordered pairs over and over again. So we're looking at option 2. That's all you need to know for that problem. And then the last exercise here, we drop a ball off the top of a 50-foot building, and then we have this equation to represent it. And they want you to practice your calculator usage to see, how to do this. And yeah, let's just pull up the calculator real quick, which I still have open from the previous lesson, and you can type it in the way it looks, 50 minus 16, but instead of a t in the problem, we're going to write x squared. And if you go back to your graph, you might not see it because we still have our window set up from the previous. Now, at any point, you can actually go back to the standard window if you hit zoom, and then the 6th option down says standard. But even then, you don't see what the graph really looks like because the window needs to go all the way up to y equals 50 because that's how tall the building is. And you might also change your window to say, well, I don't care about negative numbers. So change the x to be 0. And you're making your graph look a little bit nicer. Maybe x values of 5. All right, I need to hurry up. What they want you to do is look at your table. So if you hit second window, you can actually change your table to start at 0, but count by tenths. Changing table to count by tenths. So if you hit second graph, you can actually scroll down. I need to hurry up because I'm almost out of time. Oh, there it is. to change from a positive to a negative, I would say 1.8 would be when it hits 0.